8.2 is going to introduce linear functions. So a linear function, when you graph it, is a straight line, meaning it either goes up or goes down, has a constant rate of change. It's always the same between every 2 points. We call that a slope. So the rate of change you usually see when we're talking about word problems, the slope is what you're going to see in an equation. It always has an exponent of 1, the highest exponent, so you're never going to have anything higher than an x there. Slope-intercept form looks like this, mx plus b. What that means is m is your slope, and b is the y-intercept, or the initial value, and you can use that to write an equation. For example, this first one, if we look at x, there's no exponent, so it is linear. The slope is with the x, so it would be -3. The y-intercept is the other number, so it'd be 4. Okay, let's look at the next one. Here, there's only a number, but it would be like saying 0x. If we were to graph this, it would be straight line, so it is linear. Our slope is just 0, and then our y-intercept would be 8. For this last one, we have an exponent of 2, so there's no way it's not linear, so we don't have to find a slope because there's one. All right, let's look at a word problem where we might see this. Under ideal conditions, some species of bamboo can grow at a rate of 2 inches per hour, and suppose a bamboo plant is initially 6 inches tall. Find a function that models the plant's height. So our function is h because they tell us that, and instead of x, we're going to use t. Now our slope is the constant rate of change, so this would be 2 inches per hour. So that's going to be our x, 2x. And then we're initially 6 inches tall, so we would add 6. There's our equation. Now we're saying find h of 3 and interpret, so we plug 3 in for t. 2 times 3 is 6, 6 plus 6 is 12, so there's our value. And the interpretation of that is that at 3 hours, the plant would be 12 inches tall. Another problem, the table shows projected sales of green building materials in billions. So all those numbers in sales are actually billions of dollars. We're going to make a scatter plot using 2015 as 0, 2016 as 1. So what that means is instead of typing those huge numbers in the calculator, we're going to type 0, 1, 2, and 3. So if I go in my little calculator here, go to my stat, edit, 0, 1, 2, 3 is the L1, those are our X values, and then the sales we put in L2. Now to see that scatter plot, this one doesn't give us a window, but there's a trick. If you hit the zoom button, that's the top middle, and then go down to number 9, which is stat, that's telling the calculator to zoom into what you have listed in the stat menu. Then you can see your scatter plot. If this was a test question, you could draw it out by hand and send me a picture, or you could just take a picture of your calculator and send me that in an email or upload it right to the question, whatever's easiest for you. Now, what were the sales in 2015? So if we look at this first box, the sales were 72 billion. That's our initial, that's when we started. What is the annual increase per year? So that's our rate of change. To find those increases, we need to subtract. So 93 minus 86 is 7, or 79 minus 72 is also 7. So our increase per year is 7. To write a formula for that, we'd say f of x, our slope would be the 7x, and our 72 billion would be the initial value. Estimate the sale in 2019. So if 2015 is year 0 and we follow up the chart, 2019 would be year 4. So to estimate that value, I'm going to plug 4 in for x. If I were to type that in the calculator, I'd get 100 billion. So this formula is predicting that we have $100 billion in sales at that point in time. All right, the last formula we're going to talk about is the midpoint formula. This is saying, hey, if I give you these 2 points on a line, can you find the point exactly in the middle? So to do that, it's like averaging the x values, and it's averaging the y values, and then where those points meet, it gives you the midpoint. So if I did that, we're going to add the x. So -2 plus 4 divided by 2. -2 plus 4 is 2. 2 divided by 2 is 1. Do the same thing with the y's. 1 plus negative 3 is negative 2, and negative 2 divided by 2 is negative 1. So if I were to graph these 2 points on the line, this would be the point exactly in the middle. Pause the video and try the other one. All right, add my x's. Negative 3 plus 4 is 1, divided by 2 is 1/2. The y's, we've got negative 2 plus 1, which is negative 1, divided by 2 is negative 1/2. That would be our midpoint. Now let's look at this last thing here. The divorce rate per 1,000 people in 2000 was 4.2, and in 2014 was 3.6. Assuming that's linear, use the midpoint formula to estimate the divorce rate. So our x's would be our years. 2000 plus 2014 is 4014, divided by 2 is 2007. The y's are going to be our rates. So 4.2 plus 3.6 is going to be 7.8, divided by 2 is 3.9. So the divorce rate in 2007 would be 3.9. Could we use the midpoint formula to estimate the divorce rate in 2003? Well, let's see. We have 2000. Then we said 2007 was in the middle. Then we said 2014 was here. So 2003 would fall somewhere in here. And the exact midpoint would be 3.5, which is still 2003. So yes, we could use the midpoint formula, but now we're finding the midpoint between those two. So we would use the 2000 information and the one we just found to get that midpoint. It's just a way to think about how you could get it. So that's 8.2. Let me know if there's any questions.